So what is Xamarin Forms? Xamarin Forms is a library that enables you to build native apps for iOS, Android, and Windows using a single C# codebase. If you have any experience with Windows Presentation Foundation or Silverlight, Xamarin Forms will be very familiar to you. So we have this XML-based language called XAML, which stands for Extensible Application Markup Language. And we use this to define the user interface of our applications. For example, we can define what elements we have on a page, where they are located, and what do they look like. Behind every XAML file, we have what we call a code behind, which is basically a class that implements the behavior for that page. For example, what should happen when we click a button or select an item from a list. So these are the responsibilities of the code behind. Now, in terms of architecture, Xamarin Forms is built on top of two existing libraries, Xamarin.Android and Xamarin.iOS. So with Xamarin Forms, we worked with a single, unified API for creating user interfaces. And Xamarin Forms will internally map these user interface elements to their corresponding native equivalent. And this makes our applications completely native. So we don't have user interface elements that look the same across different platforms. If you use a button, that button looks different depending on where you run your application. Also, because Xamarin Forms is built on top of Xamarin.Android and Xamarin.iOS, you can write platform-specific code that uses the API exposed by any of these libraries. So you're not limited to a common set of features that are available across all these platforms. Now, the first question that a lot of beginners ask me is, Mosh, do I need to know about Xamarin.Android or Xamarin.iOS in order to learn Xamarin Forms? Not at all. The only exception is if you want to write something specific for Android or iOS. Otherwise, for the most part, you can learn Xamarin Forms on its own. The second beginner's question is, how do I know which Xamarin product should I use? Should I use Xamarin Forms or one of the more specific libraries? The answer is it depends. What makes Xamarin Forms powerful is the ability to share most, if not all, your code across these platforms. So you code the application once, and then build it for different platforms. This building is nothing more than just a compile in Visual Studio. That's all you have to do. So if you don't need to use much of the platform-specific functionality and code reuse is more important to you, then go for Xamarin Forms. Otherwise, if you're going to do a lot of customization and have quite a few use cases for working with platform-specific API, then it's better to use Xamarin.Android or Xamarin.iOS. In terms of tooling, you have a few options here. If you have a Windows machine, you can build and deploy apps to Android and Windows, but not iOS. For that, you need a Mac, either a MacBook Pro or an iMac. On the other side, if you're a Mac user, you can build apps for Android and iOS, but not for Windows. So if you want to target all platforms, you need both a Windows and a Mac machine. But this is not a requirement to take this course or to learn Xamarin Forms in general. It's all about where you want to deploy your application. You can start with a Windows machine and use Visual Studio to build apps for Android and Windows. If in the future you want to build your app for iOS, you just add a Mac to your setup and you're pretty much done. You don't need to write any new code. You just build your project for iOS. All right, next I'm going to show you how to set up your development environment. In this video, I'm going to show you how to set up Xamarin on a Windows and a Mac machine. I'm going to start off by setting up on Windows, and then I'll get to Mac. Whether you're a Windows or a Mac user, be sure to watch this video thoroughly. So if you're a Windows user, you probably have Visual Studio. So you can install Xamarin, and that will install all the required SDKs as well as project templates in Visual Studio. So simply head over to xamarin.com/download. Fill out this form and be sure to set the answer of this question, I already have Visual Studio installed, to yes. So you don't get Visual Studio. You only get Xamarin Installer. Once you run it, you're going to see a dialog box like this. Be sure to select the following items under cross-platform mobile development. So the latest version of C#/.NET, Xamarin. So you see I've currently installed version 4.0.3. But there is a newer version, so I'm going to tick that. And then under Common Tools and Software Development Kits, select Android Native Development Kit. You see I've installed both the 32-bit and 64-bit versions. You also need to install Android SDK, and then you need to install at least one of Android SDK setups. The difference between these items are their version number. So you see the first item is API level 19 and 21, and the last one is API level 23. You can go for the last version, or if you have enough space on your machine, you can install all of them. Apache Ant is not really necessary, but I have installed it anyway. And finally, you need to select Java SE Development Kit. Now, if you have a typical machine and are not part of a network with a proxy server, this installation process goes very smoothly. But it may fail if you're behind a proxy server or if you're running Windows in a virtual machine on a Mac. This happens mainly because Xamarin Installer cannot download some of the required resources. So at this point, you need to manually install some of these components. I've attached a PDF to this lecture with more details about manual installation. So hopefully you won't have any problems during the installation, but if you encounter any issues, you really need to troubleshoot them yourself. Because every machine is different in terms of the hardware and software, and I really cannot help you with that. So just Google the exact error message you get, and you will definitely find a solution. I just want to emphasize, do not get discouraged if you get any errors. You only need to spend a bit of time to troubleshoot these issues, and then everything is going to be fine. Also, it would be really helpful if you post the errors you get and the solutions you find in the discussion board, because I can get all these various errors and compile them into a PDF, and that would be a very valuable resource for future students of this course. Now, what if you're a Mac user? You have two options. You can either use Xamarin Studio on a Mac, which is a lightweight IDE similar to Visual Studio, or you can use Visual Studio, but this requires a Windows machine. In my setup, I'm running Windows as a virtual machine using VMware. Which option is better? Xamarin Studio is the fastest option. You simply head over to xamarin.com/download and get Xamarin Studio and you're good to go. You can build apps for iOS and Android, but not for Windows. If you want to target Windows, you need a Windows machine, so you can either get a physical machine or use a virtual machine like me. Then you need to follow the same steps to install Xamarin on your Windows machine. In this video, I'm going to show you how to create a Xamarin Forms app in Visual Studio. Whether you're a Windows or a Mac user, watch this video thoroughly. So here I'm using Visual Studio 2015. Let's create a new project. Under Visual C# Templates, select Cross-Platform. For Xamarin Forms apps, we have two options here: Portable Class Library or Shared Assets. The preferred way and the best practice recommended by Xamarin is a Portable Class Library. If you want to understand the differences between these two project types, I've attached a PDF for you for further reading, but read it after watching this video. So let's go ahead with this Portable Class Library. I'm going to call our application Hello World. Okay. Now this process is going to take a few seconds, so I'm going to pause the recording. Okay, next you're going to see this dialog where we select the target and minimum version for Universal Windows apps. A Universal Windows app can run under Windows 10 or Windows 10 Mobile without the need to be rewritten for each. I'm going to accept the defaults here. Okay, our solution is ready. Now, before looking at the structure of the solution, as a best practice, whenever you create a new Xamarin Forms app, right-click the solution and go to Manage NuGet Packages for Solution. Then go to the Updates tab and make sure to select all packages and update them, because Xamarin frequently releases new libraries. Okay, as part of this update process, one of the older packages is going to be uninstalled. And for that, you need to restart Visual Studio. So, restart. Yes. Okay, all the packages are updated properly. Now let's see what we got here. So in this solution, we have 6 projects. The first one is our Portable Class Library. And this is where we're going to do most of the work. So all the code that should be shared across different platforms should be written here. And if you look inside, we only have one class, app, which is the starting point of our application. Next, we have 5 platform-specific projects. One for Android, one for iOS, one for universal Windows apps, which can run on Windows 10 or Windows 10 Mobile, and one for Windows 8.1, and the last one for Windows Phone 8.1. So anytime we want to write platform-specific code, we'll write it in these projects. Now, as I explained before, the whole idea about Xamarin Forms is about code reuse. We want to write code that can run across different platforms. That's why we do most of our work in the portable class library. All these projects you see here have a reference to this class library. Now, if you don't have a Mac, you're not going to see this iOS project here. Also, let's say you only want to build an app for Android and don't care about other platforms. You can simply delete these projects here. And if in the future you decide to support them, you can simply right-click the solution, add a new project. Let's say you want to target iOS, then under iOS, expand it, universal, and here's the blank app template. So you just add a project to your solution and you're good to go. Okay, now let's run this app. You can see that currently hello world.droid is set as the startup project. So if I press Ctrl and F5, it's going to be loaded in an Android emulator. Here on the toolbar, you can see the list of emulators installed on my machine. These emulators come as part of installing Xamarin. So if everything goes well during the installation, you should see quite a few emulators here. But in my case, because I'm running Windows in a virtual machine on a Mac, I had to manually install Android emulators. If you want to deploy and debug your application on a real device, you need to set it up for development first. And then you can see it listed here. So you simply select it and then press Ctrl F5 to deploy and run the app on your device, or F5 to debug it. And these are the shortcuts that we always used in C# development. I've attached a PDF to this lecture with additional details about setting up your Android or iOS device for development. Now let's run this app. Ctrl F5. Now, the first time you launch Android emulator, you're going to wait quite a few minutes, even up to 10 or 15 minutes, depending on your hardware. So please be patient. And here is my Android emulator, and you can see our first Xamarin Forms app is running successfully. So this app is just a single page with a label in the middle of the screen. Now, your emulator may look different in terms of its size and the controls you have here. But all these are settings that can be changed when creating an emulator manually. Now let's say we want to run this app in an iOS simulator. So we right-click the iOS project and set it as a startup project. Then on the toolbar, I can either deploy it to my device because I have an iPhone, or use one of these simulators, iPhone 4, 5, 6, iPad, and so on. Now, this simulator actually runs on my Mac, not on the Windows. And here on the toolbar, we have this icon, Xamarin Mac Agent. If you don't see this toolbar, go to the View menu. Under Toolbars, select iOS. We also have a toolbar for Android, but I have disabled it for now. So with this Xamarin Mac Agent, we can select the Mac on our network that is responsible for launching the simulator. So Visual Studio talks to a Xamarin agent on a Mac in order to launch a simulator. In most cases, your Mac should be automatically detected. But if not, you can simply click Add a Mac, add the IP address here, and you're good to go. Just remember, you need to install Xamarin both on your Windows and on your Mac machine. Now I can press Ctrl F5, and this will launch my iPhone simulator on my Mac. Okay, and here's the same app running in an iOS simulator. Next, I'm going to show you how to create a Xamarin Forms app using Xamarin Studio. All right, now I'm going to show you how to create a Xamarin Forms app in Xamarin Studio on a Mac. If you're a Windows user, you can skip this video, but I encourage you to watch it just to get familiar with what your development environment on a Mac would look like. So here I'm using Xamarin Studio version 6, and I've changed my theme to dark. Let me show you how to do it. So on the top, Xamarin Studio, Preferences. under Visual Style, set the interface theme to dark. All right, now let's create a new solution. Under Multi-Platform category, select App, and then Forms app. Next, I'm going to call this Hello World. You can see both Android and iOS are checked, but we don't have a checkbox for Windows, because in Xamarin Studio, you cannot target Windows. And for that, you need Visual Studio. Now, in terms of the shared code, the default setting is on Use Portable Class Library. The other option is Use Shared Library, which is not something I would recommend. Again, if you want to know the differences between a portable class library and shared assets, look at the PDF I have attached to this lecture. Next, I'm going to accept the defaults here, which are about location, version control, and test cloud. So nothing important at this point. Create. Okay, our project is ready, and this is much faster than Visual Studio. Now, as I told you in the last video, as a best practice, whenever you create a new Xamarin Forms app, make sure to update all the packages. So right-click the solution and go to Update NuGet Packages. You can see Xamarin Studio is updating the packages, and this is going to take a little while. Okay, all packages are successfully updated. Now, similar to Visual Studio, you can see that the iOS project is set as the startup project because it's bold. And here on the toolbar, we can select a simulator. So we've got various versions of iPhone and iPad, or we can deploy to a real device. Now to run this application, you press Command, Alt, and Enter. And then iOS Simulator launches and loads our application. If you want to try the Android app, right-click this project and set it as Startup Project. Now you see all the Android emulators here. So throughout this course, I'll be using Xamarin Studio to do my development because it's much faster and more lightweight. If you want to use Visual Studio, that's perfectly fine. All the code I'm going to write in this course is exactly the same. And it doesn't matter which IDE you use. It's entirely your personal choice. All right, next we're going to explore this application in more detail and add a bit of functionality. So you will see both XAML and code behind in action. All right, this is what I'm going to build now. I want to add a new page to our app with a button in the middle of the screen. In iOS, buttons don't have a border. They look like labels. So when we click this button, we get an alert. So let's go ahead and implement this. All right, as I explained in the last lecture, I'm going to use Xamarin Studio in this course to doing my development. If you want to use Visual Studio, that's perfectly fine. All the code I'm going to write is exactly the same. So as I told you earlier, in Xamarin Forms, we use XAML, which is an XML-based language, to define the visual appearance of our app. And we use code behind to implement how the user interface behaves. So I'm going to right-click our portable class library and add a new file. On the left side, select Forms, and on the right side, select Forms, Content Page, XAML. And now we give this a name, Greet Page. If you're using Visual Studio, again, right-click the portable class library, add a new item. In the list of templates, select Cross-Platform, and here select Forms XAML Page, and call it Greet Page. So this will add two new files to our project. One is greetpage.xaml, and if you expand it, here's the code behind, which is just a simple C# class. And we have the same scenario in Xamarin Studio. So here's our code behind, and here's our XAML file. As you can see, XAML is based on XML. The root element here, content page, represents the type of our page. In Xamarin Forms, we have a few page types. We have content page, master detail page, navigation page, carousel page, and so on. We use content page to present some content to the user, whether that being text, images, or the combination of the two. Now let me break up this line so you can see more clearly. In our content page element, we have a couple of XML namespace declarations. The first one is owned by Xamarin, and this namespace is for elements that have no prefix, like this content page element. So this element belongs to Xamarin Forms. We have another namespace declaration which identifies a prefix. So this :x syntax is used to declare a prefix. And if you look at the URI assigned to this XML namespace, you can see that this namespace is owned by Microsoft, which represents the standard XAML that Microsoft introduced in year 2009. Now, what is this :x here? That means any elements or any attributes that is prefixed with an X belongs to this namespace. Look at this attribute, the class attribute. It's prefixed with an X, and we call it X class. So this attribute belongs to the Microsoft namespace. Now look at the value assigned to this attribute. It's hello world.greetPage, which is the fully qualified name of our code behind class. So if we switch to the other tab, look, the name of our class is greetPage, and it's placed in hello world namespace. So using X class attribute, we establish a link between the XAML file and the code behind file. Now remove the content of this content page element. And instead, let's add a button. So button. I want to put this button in the middle of the screen. So we set horizontal options to center and vertical options to center. Next, we set the text attribute, click me. So this way with XAML, we're defining the visual appearance of our page. Now what about the behavior? When we click this button, I want to display an alert. In Xamarin Forms, buttons have an event called clicked. So we set clicked to a string, and this identifies the name of the method in the code behind that should be called when this event is raised. You can see Xamarin Studio or Visual Studio is suggesting a name for this method, handle_clicked. So we press enter. That brings us to the code behind. Press enter again, and that generates our event handler. So this event handler, as you see, it's a private method because it doesn't have an access modifier like public. It has two arguments. One is an object, which is the sender or source of the event, and the second one is event args, which brings additional details about an event. If this method looks strange or unfamiliar to you, I highly recommend you to watch my C# Advanced course, because there I have a complete lecture on events and handlers. Now, I want to change the implementation of this method. To display an alert, we call display alert method. We inherit this method from content page class, which is the base class for our greet page. So the arguments we supply here is the title of the dialog box, the message we want to display, like hello world, and a label for the cancel button. Let's just call this OK. Potentially, we could supply another argument if you want to have two buttons, like OK and cancel, or yes and no. But for this video, we don't have to worry about it. Now, in terms of clean coding, we should keep the constructor of our classes on the top. So I want to move this method down. Okay, we're done with this new page. Now we want to make sure that this page is displayed when our app is started. So back to our solution view. In the portable class library, you see we have a file called app.xaml. Let's expand this. Here's our code behind. You can see here main page property is set to a new instance of hello world page. Main page is a property that is defined in the base application class, and we use that to set the starting page of our application. So I'm going to change this to new greet page. Now let's run this. In Xamarin Studio, I'm going to press Command, Alt, and Enter. In Visual Studio, you press Control and F5. But before doing so, make sure in the Solution Explorer, set one of these platform-specific projects as the startup project. I'm going to use iOS. You can use whatever you want. So let's run the application. Okay, here's our button. So now you have an idea of what it's like to build cross-platform apps using Xamarin Forms. So you have seen Xamarin Forms in action. And you know that with Xamarin Forms, you can build native apps for different platforms. But you might be curious how Xamarin actually achieves this. So let me give you a bit of background. All Xamarin products, like Xamarin.Android, Xamarin.iOS, and Xamarin Forms, are built on top of Mono, which is an open source version of .NET that runs on various non-Windows platforms, like Linux, Unix, and OS X. Mono is a project that has been around since pretty much as long as .NET itself, but it wasn't very popular until recent years. In the Mono world, we had two releases. One was called Mono for Android, which was later renamed to Xamarin.Android, and the other release was Mono Touch, which is now what we call Xamarin.iOS. Both these libraries give you access to the .NET base class library. So you have the same namespaces you are familiar with. You got the same classes with the same interfaces, but they also give you access to the native API on their platform. So you have access to additional assemblies and namespaces that mimic the ones that come natively with Android and iOS. These are the classes that Objective-C or Java developers work with when they build native apps for Android and iOS. When using Xamarin.Android or Xamarin.iOS, we work with these classes just like standard C# classes in .NET. And these libraries will internally call the corresponding API on the target platform. Now, how that happens, it's pretty complex and it's not something we need to worry about. That's something that developers at Xamarin have to deal with. Now that you have an understanding of Xamarin.Android and Xamarin.iOS, let's get a little bit more specific here. When you build an application with Xamarin.Android, Xamarin C# compiler compiles down your C# code to intermediate language or IL. It also embeds the Mono runtime with your application. This Mono runtime is similar to CLR that you should probably be familiar with. So when you launch an Android app, this runtime is loaded into the memory, and then it gets your IL code and compiles it to the native code for Android. And this process is what we call just-in-time compilation or JIT. This is the same mechanism that is in place when you build a regular .NET application with C#. When you build a console, desktop, or web application, the same magic happens. Now with iOS, we have a different story. Apple does not allow JITting. So when you build your iOS application, Xamarin C# compiler first compiles your C# code down to IL, and then it uses Apple compiler to compile it to native code. And that's why you need an Apple machine. So the output is native code that iOS can understand, and there is no JITting involved here. In other words, when you ship your application, there is no Mono runtime embedded in your application. So this is how Xamarin.Android and Xamarin.iOS work. But what about Xamarin Forms? Well, Xamarin Forms is built on top of these two libraries. So we have this assembly called xamarin.forms.core, and here we have classes that define a common unified API to work with different platforms. For example, we have a class called button, and this is the button that we reference in XAML or in code behind. Now, we have another bunch of platform-specific assemblies that map these common objects in Xamarin Forms to their corresponding native equivalent. Let me show you. So here in this blank solution, let's expand this portable class library. Now, under references, under from packages, look, we've got xamarin.forms.core. And this is the assembly that defines that common API that we work with. So here we've got classes like button, label, list view, page, and so on. Now, if you look at one of the platform-specific projects, like the Android one, again, under references, from packages. Now here we have an assembly called xamarin.forms.platform.android. And this is the assembly that is responsible for mapping those common controls we have in xamarin.forms.core into their corresponding Android equivalent. And in this assembly, we have a bunch of what we call renderers. So these are the classes that know how to render, for example, a label or a button. Now we have the same architecture in other projects. So Let's expand the iOS project, references, from packages. Now look, we've got xamarin.forms.platform.ios. So this is how Xamarin Forms works. All right, let me quickly give you an overview of how I have structured this course and where you will find the content you're looking for. In the next section, you're going to learn the basics of XAML, and this gives you a good foundation to progress through the rest of the course. Next, we're going to look at layouts, which we use for arranging visual elements on screen. So you will learn how to build user interfaces like these. Next, you're going to learn about images. You will learn about downloading images from the internet or embedding them in your applications. You will also learn about icons. After that, we're going to look at lists. So you will learn how to present data in beautiful interactive lists. Following that, we're going to look at navigation. You will learn how to navigate users from one page to another, how to implement master detail, how to implement tabs, how to display pop-ups, and so on. Next, you're going to learn how to accept input from the user, and this will help you build forms and setting pages. But we are not going to talk about saving or loading settings in this section. That's the topic for the following section. So in data access section, you will learn various ways you can store application data. You will learn about application properties. You will learn about file system. You will learn about storing structured data in a SQLite database. And finally, you will learn about consuming RESTful services. Now, if you don't know what RESTful is all about, don't worry. I've got some PDFs for you, so you're in good hands. Next, we're going to look at MVVM architectural pattern. I will explain what MVVM is, when you should use it and why, and how to implement it. But briefly, we use MVVM for decoupling our application from a presentation framework like Xamarin. And we do this for testability. So at the end of this section, I've got a short video where I show you how to unit test your view models. More on this later. And finally, in the last section, we're going to look at some more practices and features that are useful in building larger complex applications. And in this section, I will show you some of the useful plugins that you can use to access common device functionality, like using the camera, GPS, checking the status of the battery, detecting motion, accessing contact book, and so on. So there is a lot to cover over the next 7 hours, and I hope by the end of watching this course, you will have a very solid foundation to build cross-platform mobile apps using Xamarin Forms. Well, hello, it's Mosh here. I hope you've been enjoying watching my Xamarin Forms tutorial. In case you didn't know, this tutorial is the first hour of my comprehensive 7.5-hour course on Udemy. In this course, you will learn how to build native mobile apps for Android, iOS, and Windows with C#. If you're interested to have this course, you can get it with a big discount using the link in the video description. And if not, that's perfectly fine. Continue watching as the next section is coming up. So, as I explained in the last section, XAML is an XML-based language that we use to define the visual appearance of our applications. We are going to use XAML a lot throughout this course. So in this section, you're going to learn XAML in more detail. And by the end of this section, you will have a good foundation that will help you progress through the rest of the course. So let's get started. Okay, continuing from the project we created in the last section, in our greet page, first I'm going to delete this button. And then in the code behind, I'm also going to remove this event handler. Now back in the XAML file, I want to put a label on the page. So label, I want to put it in the middle of the screen. So horizontal options, center, vertical options, center, and text, hello world. Now we can create the same UI using code instead of XAML. Let me show you how. So back in the code behind, in the constructor, after the call to initialize component, we can set the content property of our page. This property is derived from content page which is the base class for our greet page. Now we can set this to a new label and set its properties here. So horizontal options, we set this to layout options, which is an enumeration, .center. Similarly for vertical options, .center, and finally text. Now don't worry about this red line under initialize component. I think there's something wrong with my Xamarin Studio. Now that aside, you can see that we can create user interfaces using code as well. In this case, I'm setting the content property to a new label. And this is exactly equivalent to what we put between opening and closing tags of content page element. Now you might ask, Mosh, why do we want to create user interfaces in the code as opposed to XAML? Well, in more than 90% of the cases, we would use XAML. You would use code only if you want to add elements on a page dynamically. For example, depending on different circumstances, you may want to add a label or a button or a slider or whatnot. And all this can happen dynamically. But as I said, this is the kind of behavior that most applications don't exhibit. So all I want you to take away here is that if you want to put elements on a page dynamically, you can do it in the code. Now, why is XAML better than the code? Because it's cleaner and less noisy. Look at these properties here, horizontal options and vertical options. We're simply setting them to a string value center. Now look at the equivalent in the code. We have to prefix this value with layout options, the name of the enumeration. So there is a little bit of noise in the code. And this can get worse when you're dealing with complex hierarchical structures. In those situations, XAML is a definite winner because XML is naturally hierarchical. Now, the reality is, even when we use XAML at runtime, we have a XAML parser that reads this XAML file and it will instantiate objects just like the code we have written here. So the exact same code will be executed by the XAML parser. Let me show you when it happens. So in the solution, I'm going to right-click the solution and set display options to show all files. If you look at the object folder under debug, we have a file here, hello world.greetpage.xaml.g, which stands for generated.cs. So this class is automatically generated for us. You can see it's a partial class, so part of that is here, and the other part is in the code behind. You can see here we have a call to initialize component method. Now you might think this method is inherited from content page, but no, it's not there. It's defined in this generated code. Look, it's here. And inside this method, we have a call to load from XAML. So when we compile our application, our XAML files are embedded in our assembly. And at runtime, when initialize component is called, this XAML file is extracted from the assembly and passed to the XAML parser. Then XAML parser will take that XAML and generate a user interface like this. All right, so for now, I'm going to delete this code here. And we're just going to stick to XAML for creating user interfaces. Next, I'm going to talk about content property. All right, now let me show you something. I want to put a slider below this label. Slider. But if I run this application now, we only see the label, not the slider. But why is that? All right, let's have a look at Xamarin documentation to figure out why. So I'm going to search for Xamarin content page class. All right, look at the declaration of content page class. This class is decorated with an attribute called content property. And in this attribute, we have a string which specifies one of the properties of content page. In this case, the name of that property is content. And you saw that in the last lecture. We set the content property to a new label. Remember? Now let's look at the declaration of the content property. Look, here's the content property. Its type is a view. View is the base class for all our visual elements, like buttons, labels, sliders, and so on. So because the type of content is view, we can set it to an instance of a single view, not multiple views. That's why we cannot have multiple children or multiple widgets or multiple views inside content page element. So what's the solution? Let me introduce you to a new element. Stack layout. And then I'm going to move these two widgets inside stack layout. With stack layout, we can stack multiple widgets horizontally or vertically. Now I want to make sure both the label and the slider are in the middle of the screen. So I'm going to grab these two properties, horizontal and vertical options, and apply them to stack layout. Now let me run the application again. And here's the result. So here's our label and here's the slider. Now let's inspect stack layout class. So we search for Xamarin stack layout class. Look, this class derives from layout of view. Now, if you look at the declaration of layout class, you can see the content property attribute again. And look, the name of the content property for the layout is children. So let's look at the children property. Now, if you scroll down, you're not going to see that children property. You have to navigate up the hierarchy. So we go to the layout class. And layout class implements iLayout controller. Let's look at this interface. Now look at the children property. It's of type iReadOnlyList. So this children property, because it's a kind of list, it can contain multiple widgets. And that's the reason we can use a stack layout to stack multiple widgets on the screen. All right, next we want to take this application to the next level. So we want to add this behavior such that when we move this slider, the label is updated to show the current value of the slider. All right, now we want to take this application a little bit further. So we want to add this behavior such that when we move the slider, the label is updated to show the current value of the slider. To implement this, we need to handle the value change event of the slider. And then in our event handler, we can get the current value and then set the label. So pretty basic. In the first section, you saw an example of handling the click event of a button in Xamarin Forms. So the technique we're going to use here is exactly the same. For the slider, we handle the value changed event and set this to the name of a method in our code behind. So enter, enter. Now I'm going to move this down. Okay, inside our event handler, we can use this e argument passed to this method to get the new value of the slider. But we need a reference to the label so we can set its text. How do we do it? Well, back in our XAML, I'm going to give this label a name or an ID. So we use one of the attributes defined in Microsoft namespace. So x:name. This x is a prefix which is declared in the XML namespace declaration for Microsoft namespace. So this name attribute belongs to the standard XAML that Microsoft introduced in 2009. And it's applicable in other frameworks that use XAML, like Silverlight or Windows Presentation Foundation or Xamarin Forms. Now we set this name to an identifier, like label. Now when I save this file and go back to the code behind, I can type label dot, and here we have access to our label. So we can set the text property. I'm going to use string.format, value is, provide an argument here, and then set it to e.newValue. Now the value we get here is a floating point number between 0 to 1. And there are a lot of digits after decimal point. So I would like to format this value to a fixed point with 2 digits after the decimal point. So let's run the application. Okay, now if I move this slider, look, the value is updated. And this is a pattern that you see in a lot of real-world applications, but the value may be displayed as percentage. Now there is just one tiny problem with this application. Let me restart it. The label is displaying hello world instead of the current value of the slider. To fix this, in the constructor, after the call to initialize component, we can explicitly set the value of the slider. So again, we need a reference to this slider object. So back in our XAML file, we use xName attribute and give it an identifier, slider. Save. Now back in the code behind, we can type slider.value. We can set it to 0 or 0.5, whatever. Let's run the application again. Okay, that's much better. Now let me give you a bit more insight about this xName attribute. So under the object folder, debug, open up hello world.greetpage.xaml.g.cs. Look, we have two private fields here. One is a label, the other is a slider. And in initialize component method, after the call to load from XAML, these private fields are initialized. So we have this method find by name, which is inherited from content page, the base class of our greet page. And we give this method an argument which specifies the name or the identifier for our widget. With this, after initialize component, we can access this private field, like in this case, the slider. Just remember, if you put this line before initialize component, you're going to get a null reference exception because that private field is not initialized at that point. So in this lecture, you learn how to access elements in code behind using xName attribute. Now, even though our application is fully functioning, but there is a simpler and cleaner way to implement the exact same functionality, and that's called data binding, which I'm going to show you in the next lecture. All right, now let's see how we can use data binding to implement the same behavior. Data binding is a concept that you see in a lot of UI frameworks, like WPF and Silverlight, and even in web applications, we have frameworks like Angular and Knockout, and many others that provide this concept of data binding. Basically, what it means is that we bind a property of a user interface element to a property of another object. In this case, we want to bind the text property of the label to the value property of the slider. So when the value of the slider changes, the text property of the label is automatically updated. With this, we don't have to manually handle the value change event of a slider, which means we don't need to create this event handler either. So our code would be cleaner and more maintainable. Internally, the framework itself will create this event handler based on our binding expression. So let's see how we can do this. First of all, I'm going to remove this event handler. And back in XAML, I'm also going to remove the value changed attribute of slider. Now, we want to bind the text property of the label to the value property of the slider. So we need to use a special syntax for this. So far, all the attribute values you have seen have been strings. At runtime, these strings are converted to a primitive type or an object using a type converter. In case of data binding, we cannot convert a string value to a binding expression. That's why we need a special syntax, and in XAML, this is called XAML markup extensions. So we use curly braces to instruct XAML parser that this is not a string literal, and it's a markup extension. There are many different markup extensions available in XAML, and in this video, you're going to learn two of them. The first one is binding. So, curly braces, binding. Now, to set up binding, we need to specify what object we want to bind the text property to. So we set source to. Now here we want a reference to the slider object. That's when we use another markup extension. So again, curly braces. Now this markup extension is called xReference. So x:\reference. And we use that to reference another object in this XAML file. Note that it's prefixed with X, which means this belongs to the standard XAML that Microsoft introduced in year 2009. If you work with other XAML-based frameworks like WPF or Silverlight, you would see this. Now, after X reference, space, we need to specify the name of the target element. In this case, slider. And this is based on the value of XName attribute. All right, so here's the source object. Now, what property of this object are we interested in? The value property, which represents the current value. So, after source, comma, path equals value. We call this path instead of property because that property itself may be an object, and we may want to use the dot notation to access another property like a.b.c. That's why it's called path. All right, that's pretty much all we have to write. Now, if I run this app, this is what we get. Note the label. Previously, we formatted this number with 2 digits after the decimal point. So let's go ahead and do this. Back here. So in our binding expression, we have set up source, path, and now the third property, string format, equals, and we use single quotes to differentiate from double quotes for the value of the text attribute. Now here, we supply a standard C# string format. So value is curly braces, 0 represents the first argument, colon F2 for formatting. Now let me break this up into multiple lines. Okay, this is cleaner and more maintainable. Now let's run the application again. Okay, that's exactly like before. Now let's take this to the next level. What if we also want to bind the opacity property of the label to the value of the slider? So let's try another binding expression. Opacity, we use curly braces for markup extensions. The first markup extension is binding. Now here we need to specify the source object equals another markup extension. We use X reference to reference the slider. Then we set the path to the value property of the slider. Now we don't need a string format because opacity is just a number between 0 to 1. Now let me run this application. And here's the result. Note that the label is a little bit grayed out. And if we move the slider to the left, it becomes transparent, or if we go to the right, it becomes opaque. But look at our binding expression. These bindings are a little bit noisy. In both cases, we are using the slider as the source object. So let me show you how to remove this noise and make this code a little bit cleaner and more maintainable. We can set the binding context attribute of the label to our slider. So again, we use markup extension, X reference, slider. Now, slider will be the source object for any properties of the label, which means in our binding expressions for the text and opacity properties, we don't need to repeat this line. Remove, remove. Also, we can take this to the next level and remove path equals value and just add value, like this. So we can put this on the same line, binding to value. And same here. That's definitely cleaner. Now let's take this to the next level. I want to add a box view. A box view is a box filled with a color. So above the label, I'm going to add a box view, set its color to, let's say, green. And again, I want to bind its opacity property to the value of the slider. So opacity equals markup extension, binding. We set the source, another binding expression, X reference slider, and path equals value. Let's run this application. Okay, here's the result. Again, you see there's a little bit of duplication in this code. Both the box view and the label are referencing the slider as their binding context. So we can basically move this binding context setup from the label to our stack layout, the container for box view and the label. And this will be inherited by all the elements inside stack layout, which means we can simplify this binding expression for the opacity of the box view, remove the source, and the path. So this is how we set up data binding. Now finally, we don't really need this X name for the label because we have not referenced it anywhere. So we can delete it. All right, next I'm going to show you how to deal with device differences. All right, now let me show you something. Don't type anything, just watch. For the stack layout, I'm going to remove vertical options attribute. Let's run this application in Android and see what happens. Okay, this is what we get. Note that the box view is on top of the page, just below the blue bar. Now I'm going to run the same app in iOS. Okay, and this is what we get. Again, note where the box view is located. In Android, our page started right below the blue bar. But in iOS, our page starts right from top of the screen. So if we had some text here instead of box view, that text would clash with the current time. So this is one of the key differences between Android and iOS. In this video, I'm going to show you how to add some padding to top of the page, but only in iOS. So back in Xamarin Studio. In this video, I'm going to show you how to do this in Code Behind. And then in the next video, I'll teach you how to achieve the same thing in XAML. The reason I want to introduce you to Code Behind is so that you have better understanding of what happens under the hood. So we have this class called device. And this has a static property called OS, which is an enumeration of type target platform. So we can check if target platform is iOS. Then we set padding of the page, which we inherit from content page class, to a new thickness object. Thickness has a few different constructors, and the one I'm going to use now takes 4 arguments: left, top, right, and bottom. It's good to remember this order because you're going to use this a lot. So left 0, top 20, 0, and 0. So with iOS, we always want to add 20 pixels on top of our page, so the content of the page does not clash with the standard bar on top of the screen. Now, even though this code is perfectly fine, let's just assume we want to have different paddings for Android and Windows. So if you want to use the same technique, we would end up writing code like this: else if device.os equals target platform.android, something like this. Now don't worry about these numbers, these are just arbitrary. Now I want to show you a cleaner way to write the exact same code. This device class has a method called onPlatform. And this method has 2 overloads. One that is generic, as you see here, and the other that takes actions. I'm going to start with the generic one because it's easier to understand. So we supply the generic parameter. In this case, I want different thickness objects for different platforms. So the generic parameter is thickness. Now we can supply different thickness objects for different platforms. And to make the code cleaner, we can use named parameters in C#. So iOS, new thickness, also, you can see that thickness here is grayed out, so we can refactor this code and remove it. Now compare this code with what we wrote earlier. We don't have all this if, else, if, else, if. The code is cleaner and more focused. So internally in this method on platform, we're actually going to have code like what you see on the top. So this method takes care of all these conditional statements and returns the proper thickness object based on the current operating system. So then we can get the result from this method and assign it to padding. We can use this on-platform method with pretty much any objects. In this case, we are interested in thickness. In your applications, you might be interested on an integer being different across different platforms. Then you would supply 3 integer arguments. Now, as I explained earlier, this on-platform method also has a non-generic overload. Let me show you how that one works. So device.onPlatform, I'm going to use the non-generic overload. You can see here we have 4 parameters, and they all are optional because they are set to null. So let's say I want to execute some code only on iOS. Then I can supply the name parameter here, iOS. And here I need to specify an action. So I'm going to use a lambda expression for that, like this. Now, if you're not sure what this all means, you really need to watch my C# Advanced course because I've talked a lot about lambda expressions and actions there. So here in this block, we can write the code that we want to be executed on iOS. For example, we can set padding to thickness object. This is another way to set the padding property. Also, for discussion's sake, let's say we want to have a different piece of code to be executed on Android. Then we set the name parameter, action, we use a lambda expression, and here we write the Android specific code. So this is how we use device.onPlatform method, whether the generic overload or the non-generic one. Now, as I explained before, we aim to use XAML to define the visual appearance of our applications. So in the next lecture, I'm going to show you how to use on-platform in XAML. All right, now let's see how we can set padding using XAML. So in the last lecture, you learned that padding is a property of the page, and we can set it to a thickness object like this. And obviously, this applies to all platforms. Now, if you want to apply this padding using XAML, we can easily do so like this. So for our content page element, we set the padding attribute to a string literal. Now at runtime, XAML parser will get this string and give it to a type converter, which will parse this into a thickness object. And again, this will apply to all platforms. Now, what if you want to apply this only to iOS? Then we need to use an element called onPlatform. onPlatform. And this element has attributes like iOS, Android, and so on. But the problem is we cannot use this element as the value of the padding attribute, because these values, as you have seen so far, are either simple strings or XAML markup extensions, but they cannot be an XML element. That's when we use a special syntax in XAML called property element syntax. Let me show you how it works. So first I'm going to remove this attribute. Now inside content page element, I'm going to add another element, content page dot padding. So I'm using an XML element instead of an XML attribute to set the padding property. And that's the reason this syntax is called property element syntax, because we set C# properties using XML elements, not attributes. Now inside this element, I can either add a simple string, or I can add another element to represent a complex object. In this case, I want to use onPlatform element. So I can take this here and move it right here. Now this onPlatform element maps to a C# class. Let me show you. So back in code behind, I'm just going to declare a temporary variable, new onPlatform. So this is a generic class. And here we need to supply the generic parameter. So I'm going to use thickness here. Now this class has properties like Android, iOS, and so on. Now I can get this on-platform object and assign it to padding. There will be an implicit conversion between on-platform object and thickness object. Okay? So we want to achieve the same thing in XAML. When creating this on-platform object, we need to specify the generic argument. So we use another attribute here, X type arguments. And we set this to thickness. Again, to emphasize, because this is prefixed with X, it belongs to Microsoft namespace and is part of the standard XAML that was first introduced in year 2009. So this line in XAML is exactly like this line in C#. Okay, now we need to set properties of our on-platform object. So back in XAML, for iOS, I'm going to use 0, 20, 0, 0. And to refresh your memory, these numbers represent left, top, right, and bottom. In the last video, I referred to these numbers as pixels, but the reality is it's not a pixel. For now, for simplicity, imagine these are pixels. So now using this technique, I can apply various paddings on different platforms. I can apply another padding for Android, and similarly for Windows if you ever need to. So to recap this video, we use property element syntax when we are dealing with complex objects that cannot be represented using simple strings. All right, in this video, I'm going to show you how to catch and prevent XAML errors. So as an example, I want to remove this S here. Now let's run this application and see what happens. So the application launches and it terminates immediately. And currently, I have no idea what's going on here. In situations like this, the first thing you should look at is Application Output tab in Xamarin Studio. I believe in Visual Studio, this tab is called Output. Now, if you look at this tab, you see we have a XAML parse exception. The exception says type on platform not found. So basically what's happening here is we don't have an on-platform type that is not generic. So this is one way to find the exception. Another way is to run the application in debug mode. In Visual Studio, you press F5 instead of Control and F5. In Xamarin Studio, you press Command and Enter instead of Command, Alt, and Enter. Another option is to press this play icon on the toolbar. So let's run this. Okay, we got the exception. So we got a XAML parse exception, and the exception message is type on platform not found. Now the problem we currently have is that we will not know these exceptions until runtime. And as we're typing XAML, it's quite possible that we may make a few mistakes here and there. So is there a better way to catch these errors? Yes, there is. We can include our XAML files as part of compilation. So they will be compiled into intermediate language or IL. And this has a number of benefits. The first one is that we can catch errors at compile time instead of runtime. The second benefit is that because XAML files are compiled into IL, the size of final assembly will be reduced because these XAML files will not be embedded in the final assembly. And finally, compilation of XAML files will slightly optimize the load and instantiation time for XAML elements. Now, compilation is disabled by default, and we need to enable it, but that's pretty easy. Let's go to the solution. Under Properties, you find Assembly Info. And here we have attributes that apply to the assembly as a whole, like the title, the version, copyright information, and so on. We can include another attribute here, brackets, assembly colon, and this prefix means this attribute is applied to the whole assembly. XAML compilation. Now we get a red underline here because we need to resolve the namespace. So on top of the file, using Xamarin Forms XAML. Now the parameter to this attribute is an enumeration called XAML compilation options. the default value is skip. So I want to set this to compile. And that's all we have to do. Now, if I build the application again, look, we got an error. And here's the exact same error we got at runtime, but now we're catching it at compile time. So this is a pretty good attribute to always include in your assemblies. But just in case you need to disable it on a particular XAML file, you can simply go to the code behind for that XAML file. For example, let's say we want to disable this on greet page. So we go to the code behind, import the namespace using Xamarin Forms XAML, and then apply the attribute to the class. XAML Compilation, compilation options, skip. All right, we're done with the basics of XAML. Now it's your turn. So in the next lecture, I'm going to give you some exercises. All right, now it's your turn. I want you to use what you have learned in this section and build a simple application like this. So this is a quote application. We've got this button on the top to navigate through different quotes. And these are the quotes by Einstein. Now, when building this application, you don't necessarily have to use the quotes I've used here. You can use simple string values like quote 1, quote 2, quote 3. The point here is that you have limited number of quotes in your application. And as you click next, when you get to the end of the list, then you start over. We also have this slider for changing the size of the text. So before you get started, look at the PDF I've attached to this lecture. All the best, and I will see you in the next section. Okay, you seem to be very enthusiastic about learning Xamarin Forms. So once again, if you're interested to take my 7.5-hour course with a discount, click the link in the video description. I hope to see you in the course.